is Z. The symbol Y has been associated with Z. Now whenever we say, whenever we give the command setq quoted Y, then the symbol Y is associated as a value of the symbol X. But if we give eval X, then what would happen? That X evaluates to Y through the read eval print loop. And further this eval's occurrence evaluates its argument's value, which is Y, further. That is, the value of Y as a symbol is the symbol Z, and therefore the value of eval X is returned as Z and not Y. I hope it is clear that eval X actually evaluates the symbol X, and again whatever is evaluated further. So friends, with these, some of the more important list operations, we go to the next type of functions, which are predicates. Predicates are special type of functions in the sense that the values returned by the predicate functions is either a true or false. That is, the logical values are the values returned by the functions which are known as predicates. Now there are large number of predicates which are built in the list. We will discuss some of the more important ones as follows. Please look at the list slide. One of the operations is greater than, and it is applicable only when the arguments are numbers. So as we mentioned earlier also, the function name always, or of the operation name always comes first. Whenever we have to multiply, first of all we will write star, then followed by 2, followed by 3, which will return 6. So in this particular case, the function which happens to be a predicate, that is, which will return a value which is either true or false, the operation symbol is written greater than. Then the number 7 is there. Then the second argument is a list plus 2, 3. So whenever a function is applied, as we have mentioned earlier, its arguments are evaluated. And we have also mentioned earlier that a number evaluates to itself. So the arguments of greater than symbol are 2. One is 7, and 7 being a number evaluates to itself. But the second being a list, it is evaluated. And in the list, the first symbol is a plus. So the function plus is applied to its arguments which happen to 2 and 3. Therefore, the second argument of greater than operation, which happens to be a list to plus 2, 3. But plus 2, 3 when on evaluation returns 5. And we know that 7 is greater than 5, therefore the true is returned. Similarly, there is an operation less than. Less than 7, 3. Is 7 less than 3? No, it is false, and we know for false in Lisp the symbol nil is used. So less than 7, 3, the value returned is nil. Now there is an operation equal to. Now the equal to operation returns true if the values of its arguments happen to be equal. Otherwise it returns false. So here we have got equal to, then the first argument is a list star 3, 7, and this list star 3, 7 evaluates to 21 because star is applied. Star means multiplication is done of its arguments 3 and 7, which returns 21. Then its second argument is evaluated, which is plus 16, 5 list, and the list plus 16, 5 evaluates to 21. Therefore, the evaluated arguments of the operation equal, of the predicate equal, happen to be equal, and therefore true is returned. So far we have discussed 3 predicates, namely greater than, less than, and equal to. There is another. The equal is actually used in other ways also, which is written full equal. Equal list 1, 2, quoted list 1, 2, and we see the 2 lists are equal, and therefore it is true is written. But you should see that if the elements within one of the list is different in order than the elements in the second list, then it will not return true. So equal quoted list 2 1 is not equal to the quoted list 1 2, and therefore nil is returned. Similarly, it is not necessarily that the arguments may be given straightforward. We can use various other operations like car coder, etc., and equal quoted list AB, and the second is quoted car A, B, C, etc. Now the second argument is not quoted. So the first argument, which is a quoted list AB, evaluates to AB. However, the second is not a quoted list, therefore the operation car is applied. However, the second argument of car is a list in which the first element is AB list, and therefore the second argument also on evaluation returns the list AB. The first argument on evaluation also returns to AB, and therefore true is written. Then there is another operation even P. What is the role of even P? That its argument must be a number, and even P returns true if the number happens to be an even number. Otherwise it returns a false. So in this particular case, even P, a list is given plus 4 7, and all arguments when a function is to be applied are evaluated. Therefore this evaluates to 11, and we know 11 is not an even number. Therefore even P returns nil, that is plus 4 7 on evaluation gives 11, and which is not an even number, therefore even P returns nil. Next, even P, and again a list is given as its second argument, which is not quoted, therefore whole of it is evaluated star to 5, which returns 10, and we know 10 is an even number, therefore it returns true. Then we have other predicates. Number P is another predicate, the role of which is to return true if its argument happens to be a number. However, if its argument doesn't happen to be a number, in that case it returns nil, and we know number P 2.1417 is a number, therefore it returns true. However, number P quoted X returns nil. Why? Because the quoted X evaluates to X, and here the X stands for itself because it is the value of quoted X, and therefore it is not a number. Therefore number P quoted X returns nil. However, there may be sometimes symbols which have been associated earlier values. In that particular case, the symbol actually doesn't stand for itself, but the value which is associated with it. And in that case, the number P will not return false or nil, rather it will return true. For further explanation, let us have a look at the slide. Now let us say set Q 50 50. Please look at the slide. Set Q 50 FIFTY 50 is the number. However, FIFTY is a symbol. But because of set Q, we have associated FIFTY to the number 50, and then we say is number P FIFTY, then it will return true. Why? Because FIFTY on evaluation becomes the number 50 and hence return true. However, if we say number quote 50, now quote 50 is evaluated to FIFTY, and therefore it will return a nil. Again, there is a function number P, 0P. Now 0P's role is that it is first of all its argument is a number, and on evaluation if it happens to be 0, then it returns true, otherwise it returns false. So let us see 0P 0, yes, it is true. And if we give a command set Q X 0, then in that case the symbol X becomes associated with 0, and in that case also 0P X becomes true, because X does not stand for itself, but it stands for the number which has been associated to it or with it through an earlier instruction set Q X 0. But again we have to differentiate 0P X and 0P quote X are two different things. 0P quoted X means that the argument quoted X evaluates to X, and which is not a number. Therefore, 0p quote x returns nil. Even when the number is a very, very small number but different from 0, then also 0p returns nil. So here we are saying is 0p dot 00001, then in that case it will return false or nil. As I mentioned earlier, that the nil is used for representing false. Another predicate is null. We should differentiate between nil and null. Null is a function or a predicate which returns true or false. And null returns true when its argument is nil. And whenever its argument happens to be anything different from nil, then in that case it returns false or nil. So a number of examples are there. Null, the list, nil, yes, it is true. Null, the quoted man, then you know that quoted man evaluates to man and which is not nil, therefore null quote man returns nil. Null, the quote AB returns nil because quoted list AB evaluates to AB which is not null list, nil list, and hence null returns false. There is a very interesting predicate member. The role of member, it takes two arguments, and this member predicate evaluates its arguments and sees or checks whether the first argument occurs as a member in the second argument. If it is there, it is not there, then the nil is returned. However, if the value of the first argument happens to be a member of the value of the second argument, which must be a list, in that case the behavior is a bit different. It will not say true, rather it will give an answer which we can see from the slide, please. Please look at the slide. So first of all, we associate some value to say the symbol last alphabet through set Q. Set Q last alphabet, the quoted list U, V, W, X, Y, Z. That is the last 6 letters of the alphabet have been formed into a list and have been given the name last alphabet. Now we will like to see whether A is a member of last alphabet, and we can see that A does not occur in the value of last alphabet. The value of last alphabet is the list U, V, W, X, Y, Z. Therefore nil is written as expected. We also expect like that. However, when we try to find out whether W is a member of last alphabet or not, in that case, because W is a member of last alphabet, we expect that yes or true or T should be written. But no, it is a bit different. In this particular case, if W happens to be a member, then all the elements from W onwards are formed into a list, and that list is returned if if the first argument's value happens to be a member of the second. So you can see from the slide, member quote W last alphabet. Quote W is evaluated to W, last alphabet is evaluated to the list U, V, W, X, Y, Z. And because W occurs in this list, so all the elements from W onwards in the list to the right are formed into a list, and that list is the answer. So in this particular case, we will be getting W, X, Y, Z as the returned value on the application of member quote W last alphabet, and not T or true. How the predicate member tests the atom only for the top membership? Again, repeatedly I am saying that whenever there are arguments to a particular function, then those arguments are evaluated and only the topmost values are taken into consideration, not the deeper elements which may happen to be an element of a list which is itself a member of the given list. We have to be very careful at every stage. So for this particular purpose, please look at the slide again. Here we are saying, we are testing whether W quote, which evaluates to W, is a member of the list which is given here as U, V, and W occurs within a list, not as a topmost element of the given list. Rather, W is a member of the list WXY, which itself is a member of the given list, and in this particular case the system will return nil, despite the fact that W occurs but does not occur at the topmost element. So this type of clarification we must be very careful. Predicate equal. Friends, we discussed equal sign of mathematics, and we also discussed EQUAL. Please need not look at the slide. There is another function, or predicate rather, EQL. First of all, we discussed the two parallel bars representing equal. Then we discussed the function or predicate EQUAL. And if the elements have to be identical, happen to be identical, then the EQUAL return the value true. However, EQL, which is also a sort of equal, has a different behavior, that it doesn't see the topmost elements but rather looks into their internal structure. If their addresses also happen to be the same, and the elements at that addresses or the entities stored at that addresses are also identical, then and only then equal returns true, otherwise it returns false. That is how the two elements which are being treated for EQL, they not only should have apparent values equal, but their internal data structures, their addresses, etc., storage, etc., must be the same. For further explanation, please we have a look at the slide. The slide, the first slide says whatever I already explained, but now let us see how it works. Set Q list 1, list quote X, quote Y, quote Z. What does this mean? That this set Q will give the name to the list. The operation list, when applied to the three elements, returns the list XYZ. And this list is given the name list 1. Then you use another set Q, and here you call it list 2 and list XYZ. So please friends, we must note that each set Q stores the values at different locations, and the names are given accordingly. So here list 1, which represents the list XYZ, is stored at one location. List 2, which also happens to have the elements XYZ, but these second list, which is represented by list 2, are stored at a different location. And therefore, if you use EQUAL for the list 1, list 2, then it will return true. However, if you use EQL, then it will return false. But in the case you set Q list 3, list 1, that is list 3 and list 1 are the names of the same storage location elements, then in that case it will EQL will return true. Please look at the next slide. As I mentioned earlier, list 1 and list 2, though they have same elements XYZ, but because of the operation of set Q, these XYZs through these two set Qs are stored at different locations. Therefore, list 1 and list 2 have different storages in the memory associated with it, and therefore EQL list 1, list 2 is not true, because the internal representations are also examined by EQL. However, EQL list 1, list 3 returns true because of the fact that the last line says set Q list 3 list 1. That is, here the name list 3 and name list 1 are synonym of each other, and being synonym of each other, they refer to the same memory location, and therefore in this particular case EQL list 1 list 3 returns true. But again EQL list 2 list 3 are not representing the same memory location, therefore it returns false. Friends, these were some of the predicates. As I mentioned, predicates are functions whose values happen to be either true or false, and false in the case of Lisp is represented by nil. Now we will discuss some of operations. The operations to be discussed are, to begin with, are logical operations like or, and not. So how these logical operations are represented in Lisp and how they return values, let us have a look at the slides. Now first of all we take the simplest of the not. Not generally reverses. So whatever, if some argument is true, then not of that returns nil, and vice versa. However, in Lisp, as I mentioned earlier also, if some S expression is not nil, then always it is taken as true also. For example, the symbol man, symbol dog, anything which evaluates to something which is not nil is treated as true also in Lisp. Any non-nil entity is treated as true. So, taking into consideration this fact, we look at the various logical operations at the slide. Please, not what it does. Not of quoted list AB. I have just mentioned that quoted list AB, which is argument of not, is not nil, and therefore quoted list AB is almost a true. And not of true is nil, therefore not of quoted list AB is nil, because anything which is not nil is treated as true, and not of true is nil, therefore not of quoted list AB is nil. Not of nil is true, because not of nil, nil means false, not of false is true. Not of nil, whether you write it as a quoted list in the form of pair of parentheses, or you write NIL, both are equivalent to each other, therefore not of nil or not of empty list, both return true. Not of T is nil. Not of quoted dog. Now quoted dog evaluates to dog, and DOG is not same thing as nil or pair of parentheses. Therefore, as I mentioned, anything which is non-nil always returns true, and not of true is false, therefore not of quoted dog is nil. So friends, next logical operations are AND and OR. While applying AND and OR in Lisp environment, we must be very careful. Anything which is not nil is treated as true. And the operation of AND or OR may be different from other environments. Whenever the operation AND is applied, its arguments are evaluated one by one. Not all the arguments are evaluated necessarily. First of all, when AND operation is there, its first argument is evaluated. If the first argument happens to be nil, the operation stops. Because if one of the arguments happens to be nil, that is false, we know that application of AND will also return false, that is nil. So we go on evaluating from the left the various arguments which are given to the operation AND. And at each stage, if it is nil, then we stop the further operation and we return the value nil. However, up to a particular stage, the arguments evaluate to non-nil. And in non-nil, anything is included even quoted dog is also non-nil. So, till we are getting non-nil values of the arguments, we go ahead towards the right. And if the list exhausts, then we may return the last element, or we may return the true depending upon the situation. But if at some stage one of the arguments of the operation end happens to be nil, no further evaluation of the argument is required and nil is returned. Similarly, in the case of OR, we know if one of the argument is true, then the OR returns true. So what we do, we evaluate the arguments of OR operation from the left. At any stage, if the argument happens to be non-nil, then the value of that non-nil is returned. However, if all the arguments evaluate to nil, then the nil value is returned in the case of the operation OR. For further clarification, we have a look at the list slide, please. Now, in the case AND, the first argument is T, and as I have mentioned in the past also, T evaluates to itself. So, the first argument evaluates to true, which is not nil. We go ahead. Then the second argument is quoted dog. Quoted dog evaluates to dog. Therefore, both the arguments happen to be non-nil. And the quoted dog is the last argument, therefore its value is returned as the value of AND T quoted dog. Then we have a next and this AND has three arguments. First argument is T, the second argument is nil, the third argument is quoted dog. So first of all, the first argument is evaluated. The first argument is evaluated to T, but T is not nil. Therefore, we will go to the next argument. The next argument is nil, but nil evaluates to nil. And once, as I mentioned earlier, once any of the argument evaluates to nil, then the AND operation returns nil. That is, no more evaluation of the further arguments is taking place. That is, after getting a nil as one of the values, as value of one of the arguments, to an AND operation, we don't evaluate the remaining ones, that is quoted dog is not evaluated. We stop the evaluations only at nil. Once a nil is obtained as a value of one of the arguments to the function AND, then no more evaluations are done and nil is returned. See, OR has different behavior, but similar but different in the sense that at any stage, when true or any non-nil value is obtained on evaluating the argument, no more evaluations are done. We stop the operation and we return true or whatever is the value of the last argument. So, OR, T, nil, quoted dog, these are three arguments, but the first argument itself is not nil, therefore the OR operation returns T. Now, we take the similar, but the arguments are given in different order. OR, quoted dog, nil, T. Now, the first argument is quoted dog. Now, quoted dog evaluates to dog, and dog does not happen to be nil, therefore the dog is returned and no more evaluation of the remaining of the two arguments takes place. I hope it is very clear. One strange thing which happens to be in the Lisp environment is that the operations AND and OR may have any number of arguments. They may have one argument, more than one argument, etc. So when one argument is there, as is explained on the slide, please look at the slide, OR quoted dog. Because the first argument itself is non-nil, so OR returns dog. AND quoted dog. But because there is only one argument which happens to be non-nil, in the case of AND, we try to search for nil. But all its argument which happen to be only one argument in this particular case happens to be non-nil, therefore the last argument's value, which is quoted dog's value, is dog, and therefore dog is returned. Or nil nil. As I mentioned earlier, in the case of OR, if all the arguments happen to be nil, all, then in that case nil is returned. So with these examples we are able to explain the two major logical operations, namely OR and AND. And we also explain the operation NOT also. Friends, so far we discussed a number of operations or functions which are built in the Lisp language. But we know that programming doesn't mean that working on the basis of only the built-in operations. We should be able to define new functions which do a number of roles play in solving the problem. So what is the mechanism which is available in Lisp environment of defining new functions? So next we discuss what are the provisions in the language Lisp which facilitates definition of new functions in order to solve problems. Please, we look at the slide. The slide says that a definition for defining a new function, a list is used. That is, two parentheses are there bounding something. The very first symbol which is used for defining function is defun, D-E-F-U-N. Defun may be shortened of define function. Then whatever name you want to give to the function should be the next. And then we know for every function there has to be a parameter list. For example, if you want to define the sum of the squares of two values, then x and y will become the parameter list. And finally, how the function is achieved, the function body. So this is the outline of the structure of how a new function is defined in Lisp. This is further explained through the example. Suppose that we want to define a function which finds the sum of the cubes of two given numbers. So how we should define this function? As I mentioned, that whenever we have to define, first of all it will be written in the form of a list. That is, whatever will be there, it will be enclosed between pair of parentheses. One parenthesis on the left and one parenthesis on the right. Then the first thing which we write is defun, D-E-F-U-N. The second element of this list which defines a function is the name which we want to give to our function. So here we want to give the name SumCube, S-U-M-C-U-B-E. It may be any name, but generally the names should be mnemonic. That is, these help us in remembering how or what the function represents. So we give the name SumCube because we want to define a function which finds out the sum of the cubes of its arguments. So friends, the arguments are x and y. But how the value will be found out? First of all, we have to find out the cubes. So one of the arguments is star x, x, x. What it says, multiply its arguments, and the arguments are x, 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 so x cube is found. The second, star y, 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 which evaluates to y cube. And because we want to find out the sum, so plus is written in the beginning itself. As I have told you that Lisp is a prefix notation using language, and therefore plus comes first, then etc. the other two arguments. So what would happen? Once you give this expression in the form of a list in which the first argument is defun, second is the name of the function which is being defined, and the third is the list of the arguments which are to be parameters. So in this case, and the rest is the body of the function. What is the use of this? That is SumCube. Now, what is meant by returns? Returns is the name of the function which is returned, on which further operations can be done. So if we apply whatever is there, we make a list of that and then find out the length of the list, then it should return 1, because define sum cube xy etc., whole of this definition returns sum cube, which can be further operated upon. What we did, we made a list out of that. So sum cube when listed becomes a list of single element sum cube, and when we find out its length, then it becomes 1. So I hope what is the role of this in this particular case. How to apply a function? A function call is applied by giving the arguments some values in advance. For example, sum cube has already been defined, and here we give its 2 arguments as 2 and x. Now 2 evaluates to itself, but x should have been given some value in advance, and through set q x3 we give a value to x as 3. So sum q 2 and x evaluates to 3. So what should your function do? It should multiply 2 3 times, so it returns 8, and x is replaced by 3, so 3 is multiplied, so we get 27, and then these 2 values are added, so we will be getting 8 plus 27 is equal to 35. So friends, through this example I have explained how a new function is defined and how it is applied to its arguments. Now in the case when we are solving problems using a particular programming language, generally we have executions depending upon various conditions. For example, if we are calculating income tax, then we know that the income up to a particular limit, say 1 lakh rupees, is exempt from income tax, and the tax rate from 1 lakh to say 3 lakh is say 10%. Tax rate varies as the income increases or decreases. So in these particular cases the straightforward programming is not possible. The tax computation on an income depends upon the income, and therefore the various conditions have to be applied. If the income is less than this say 1 lakh, then no tax. When the income is between 3 lakhs to 5 lakhs, then the tax rate is say 10%. When the income is between 5 lakhs to 20 lakhs, the income tax may be 15% or like that. What this example says, this means that depending upon various conditions, the evaluation is to be done. So how to express conditions in the Lisp environment, we consider next. Please look at the slide. It is something, the word cond is used, in which test 1, S expression, etc., are there. This is the format, this is the syntax of any conditional expression. We will explain it through an example. For example, we want to find out the max 3. That is, 3 arguments are given to you. You are to return the value which is maximum of 3. So what you will do? You will write cond, condition, and if x is greater than y, then the whatever is written below it within parenthesis should be executed. However, if x is not greater than y, then whatever is written after the greater than xy clause, rest should be ignored. So we know if x is greater than y, then we should compare x with z, and if in both cases if it is true, then x is the maximum. Here one thing is that true. True means that in all other cases you should return z. So this is the syntax of the conditional expression cond in Lisp environment, and you just read yourself how the cond finds out the maximum. That first of all you compare x with y. If it happens to be, hello, okay please, thank you. Anyway, I hope with this explanation you must have understood with various important features of Lisp. We will continue with our argument of Lisp. Thank you very much.